Hi, welcome back to my channel. My name is Gina. In my video when I talk about the radiation, at the end I say that I will make another video on the Blackbody. And here's the video. If you haven't watched the video on radiation, I'll put the link up there. So today in this video we are going to cover 4 physics, function, and laws on the Blackbody. The Planck's function, Wien's law, Stefan-Boltzmann Law, and Kirchhoff's law. Let's start with a quick review. All substances with temperature above absolute zero, 0 Kelvin, emits radiation. Absolute zero is negative 273 degrees Celsius. So in other words, all the objects, all the molecules emits radiation. And at a particular temperature, there is a maximum amount of energy that an object can emit. And if an object emits at this maximum amount, then we call this object the black body. However, in real life, perfect black bodies do not exist. So here is a measure to quantify how close an object is to a black body, the emissivity. Emissivity is a measure of how closely a particular substance approximates a black body. And it's defined as the radiation per unit area from a particular substance over the radiation per unit area from a black body. So this value will range from 0 to 1. If the emissivity of an object equals to 1, it means it's a perfect black body. And if the emissivity equals to 0, it means the object does not emit at all. Even though a perfect black body does not exist, but for most solid objects, their emissivity is approximately equals to 1. And sometimes, a material may approximate a black body more closely at certain wavelengths. For example, an object can emit a maximum amount of radiation at shorter wavelength. However, it does not emit as much at the longer wavelength. So the emissivity is a function of the wavelength. Here's the function that describes the radiation emitted by a black body, and this function is called the Planck's function. This function is a function of temperature. For example, as you can see on the figure, an object at 4000 Kelvin emits more radiation at 1 micrometers compared to an object with temperature 2000 Kelvin. A perfect black body, for example, at 4000 Kelvin, it would emit this much of radiation described by the blue curve. Here are 2 laws that are derived from the Planck's function. The first one, Wien's law. And Wien's law tells you the wavelength at which an object can emit a maximum radiation. If you have taken calculus 1, you will know that to find the maximum, you take the derivative of the function and set the derivative function equals to 0. And that is how the Wien's law derived. And the second law that is derived from the Planck's function is the Stefan-Boltzmann Law. Since the blackbody radiation is a function of wavelength, so when we take the integral of the Planck's function and integrate it from wavelength equals to 0 to infinity, that will give us the total area underneath the function, which is the total energy that can emit by an object. If you don't know what is derivative and integral, I have online courses on Calculus 1 and Calculus 2, and I'll put the link down below. Calculus 1 covers derivatives, and Calculus 2 covers integrals. So when you take the derivative of Planck's function and set that equal to 0 and then isolate for lambda, that is what you'll get. For example, the temperature of the sun is around 5700 Kelvin. And when you substitute this T into the formula, and when you substitute this T into the Wien's law, you'll find that the sun emits most of the radiation in the range of visible wavelength. And that is shown on the figure. For temperature around 5000, its maximum, the peak of the Planck's function, is in the range of visible wavelength. And as the temperature of the object decreases, the maximum wavelength will increase. So luckily, sun emits its most radiation in the visible wavelength, so we can see our bright sun. Another example, temperature of the Earth is around 300 Kelvin. And when you plug this into the formula, you'll get that the Earth emits its maximum wavelength at 10 micrometers, which is in the infrared waves range. That is why even though the Earth also emits radiation, but we do not see the radiation emitted by Earth, because human eyes cannot see the infrared waves. The second law that is derived from the Planck's function is the Stefan-Boltzmann Law, which is the integral of the Planck's function, and it tells us the total amount of energy radiated by a black body. And when you take the integral, you'll get the total energy equals to some constant times temperature to the power of 4. And the constant is called the Stefan-Boltzmann constant. So as the temperature of an object increases, the more total radiation that is emitted by an object. And the last law that we are going to discuss in this video is the Kirchhoff's law. It states that for all the objects, its emissivity equals to absorptivity. In contrast to the emissivity, which tells you the fraction an object can emit compared to a black body, the absorptivity tells you the fraction of the radiation that an object can absorb from the total incident radiation. Since a black body has emissivity equals to 1, so a black body also has absorptivity equals to 1. And that is why we call this type of object black body, because all the radiation that goes to the black body, you'll get absorbed by this object. So at the end, the object will be black. So we call this type of object the black body. Here's a quick summary of what we have covered in the video. First, the amount of radiation emitted by a black body is described by the Planck's function. And from Kirchhoff's law, we know that the emissivity equals to absorptivity. So a black body absorbs all the incident radiation. And from the Planck's function, we can derive two more laws. The first one is by taking the derivative of the Planck's function and set the derivative equal to 0 to find the maximum wavelength. And that is the Wien's law. The second law is to take the integral of the Planck's function to find the total energy emitted by a black body. And this is the Stefan-Boltzmann Law. That is the end of the video. I hope you enjoyed the content. If you like my videos, please like and subscribe, and I'll see you in the next video.